Today we are stripping the skin off the global internet to reveal the industrial machine underneath. Most people think the cloud is a decentralized, ephemeral stream of data, a digital atmosphere that exists everywhere at once. They are wrong. As a professor of mechatronics, I look at the internet and I don't see a cloud. I see a massive, high-pressure hydraulic system, a rigid mechanical architecture that is currently consolidating into a single zip code in Virginia. I have spent my career dissecting control systems and physical feedback loops. I know exactly what happens to a machine when its critical components are forced into a single point of failure. In the next 10 minutes, I am going to show you the physical switchgear, the underwater chemistry, and the economic toll bridges that actually run your life. Because the internet, it does not work the way that you think. To understand the mirage, you have to look at a map of Northern Virginia, specifically a town called Ashburn. You have probably heard the myth that 70% of the world's internet traffic passes through this one spot. That figure is promotional folklore. The technical reality is even more concerning. Virginia Joint Legislative Audit and Review Commission data shows this region holds 13% of global operational data center capacity. In the Americas, that number jumps to 25%. This is not just a town, it is a global switching yard for the physical layer. The reason Ashburn exists is a mechanism called path economics. Data does not move for free. It follows the path of least resistance and lowest cost. Ashburn inherited the East Coast's dense, dark fiber geography. It sits behind the major subsea cable landings like a massive drain. Inside these buildings, the internet becomes a real estate play. We call these carrier-neutral data centers. The primary gear here is the cross-connect. This is not a digital handshake. It is a literal physical copper or fiber optic cable. Equinix reported $1,655 million in annual revenue just from these cables. When two networks want to talk, they pay rent for a cable to connect their racks. So here is the real question. If you were tasked with designing a resilient global network, would you ever allow a single metro area to hold a quarter of your continent's capacity? Or is the efficiency of the hub worth the systemic risk? But these buildings have a biological limit: thermodynamics. Every 10 megawatts of computing load requires massive cooling plants. Lawrence Berkeley National Laboratory reports a standard power usage effectiveness of 1.4. This means for every 10 megawatts of code, you need 14 megawatts of utility power. The cloud runs on heat removal. If the cooling stops, the internet melts. And right now, the grid is screaming. Dominion Energy received requests for 40,000 megawatts of new data center power. That is more power than the entire state currently generates. The internet is becoming a grid-scale variable. But while the land is heating up, the real war is happening underwater. 99% of intercontinental data moves through submarine cables. This includes $12 trillion in daily financial transactions. For decades, these cables were built by groups of phone companies. They were treated like public utilities. That era is dead. Telegeography reports that content providers now dominate the sea. Google, Meta, and Microsoft are no longer just customers. They are the landlords of the Atlantic. Look at the Maria cable. It runs 6,600 kilometers from Virginia Beach to Spain. Meta and Microsoft each own 2 fiber pairs inside that pipe. Google's Do Not cable was the first to use 12 fiber pair multiplexing. It can move 250 terabits per second. The mechanism here is vertical integration. By owning the wet plant, big tech internalizes the cost of transport. They no longer pay a middleman to move your data. They own the physics. If this breakdown is helping you see the system differently, if you are starting to see the machine beneath the mirage, consider subscribing. It helps the channel grow and allows us to build more of these structural breakdowns. But the physical object is surprisingly fragile. A typical deep-sea cable is only the diameter of a garden hose. The actual glass fibers are the width of a human hair. Telegeography reports roughly 200 cable faults every year. 70% are caused by fishing anchors and trawlers. The Internet's greatest vulnerability is a distracted fisherman in shallow water. In 2011, a 75-year-old woman in Georgia was scavenging for copper. She accidentally cut a fiber line with a spade. That one cut knocked 90% of the country of Armenia offline. When a cable breaks at 3,000 meters, you do not send divers. You send a cable ship with a dynamic positioning system. They use a cutting grapnel to hook the broken end. Repair crews wait for weeks for the right weather. The global fabric is actually a maritime pipeline project. Every few dozen kilometers, the signal needs a boost. These are called repeaters. They are optical amplifiers. It is pure physics at the bottom of the ocean. But if the physical layer is a pipeline, the control layer is a shell game. The Internet is not a single network. It is a collection of 70,000 independent networks. They use a protocol called Border Gateway Protocol to talk to each other. Border Gateway Protocol was built on a foundation of trust. It assumes that if a network says, "I own this data," they are telling the truth. But it is not a shortest path engine. It is a commercial negotiation tool. A hijack happens when a network lies about what it owns. In 2008, Pakistan Telecom tried to block YouTube locally. They announced a fake route for YouTube's data. Within minutes, the lie spread globally. The entire world's YouTube traffic was sucked into a black hole in Pakistan. This was not a hack. It was a trust-based routing error. Even today, the mechanism is fragile. In 2026, Cloudflare suffered a 25-minute outage. A single automated policy error leaked internal data paths to the world. One bad line of code misdirected the global map. Where would you place the constraint? If the Border Gateway Protocol is fundamentally based on trust, and trust is the primary failure mode of the modern web, how would you re-engineer the control layer without breaking the Internet's decentralized nature? If the Internet is a machine, who gets paid to turn the gears? It is not just your monthly bill to a service provider. The real money is in interconnection. Equinix earns over $1.6 billion annually by managing the Meet Me rooms. These are the physical chambers where networks patch into each other. They do not charge for the data. They charge for the port and the electricity. Then there is the concept of cloud egress. Amazon Web Services Direct Connect is a private on-ramp. They charge $2.25 per hour just for a 10 gigabyte port. Then they charge you for every gigabyte that leaves their network. This is the Hotel California model of data. It is free to check in, but expensive to leave. Amazon recently began waiving these fees for some users. They did this because the political pressure on the toll bridge reached a breaking point. The unit cost of moving data is actually falling. 100 gigabyte transit prices fell 12% annually since 2022. In major cities, you can move a megabit for 5 cents. But while transit is cheap, the infrastructure is consolidating. By owning the cables and the data centers, 3 companies now control the refractive index of the world. They have turned the open web into a private industrial park. The Internet is not a cloud. It is a layered industrial system. It is a bargain we made for efficiency. We moved our data into hyperscale bunkers to save power. The Lawrence Berkeley National Laboratory shows that data centers are more efficient than ever. But that efficiency came with a cost: centralization. We compressed the global brain into a handful of zip codes. We put the world's finance into garden hoses on the seabed. The Internet works exactly how it was designed. It is a machine that prioritizes the toll over the path. And as an engineer, you know the most dangerous thing about a machine. It is the part you cannot see. Because once you see the mechanism behind the mirage, you realize the cloud was never there. It was just a very expensive piece of real estate. And it belongs to someone else. We built a global system on the assumption that the cloud is everywhere. Yet we have physically anchored it to a few acres of Virginia soil and a handful of glass strands in the abyss. At what point does the efficiency of centralization become a terminal defect? If the physical fiber was cut tomorrow, which part of your life would stop first?